Hello, everyone. Welcome to the webinar, A Faster Way to Make Scene Diagrams with Drone Imagery. I'm Christine Grail from Leica Geosystems, and I'll be the moderator for today's session. Our presenter today is Andrew Klain. Andrew is a retired Massachusetts State Police lieutenant who has more than 25 years of experience reconstructing serious injury and fatal motor vehicle crashes. He is accredited by the Accreditation Commission for Traffic Accident Reconstruction, or ACTAR, and has testified numerous times as an expert witness in both district and superior courts throughout the Commonwealth of Massachusetts. An expert in the forensic mapping of crash and crime scenes, Andrew has dedicated a significant portion of his professional career to bringing technology into the reconstruction of motor vehicle collisions and crime scene mapping. This technology includes total stations, GNSS, laser scanning, and aerial photogrammetry using unmanned aircraft systems, or UAS, also known as UAVs or drones. He holds an FAA remote pilot certificate and is a proficient UAS pilot. During his time with the Massachusetts State Police, Andrew was responsible for the design and implementation of their UAS program, which is used specifically for the quick clearance of traffic crashes. As Chief Operating Officer and Principal of Forensic Mapping Solutions, Andy provides sales, training, and implementation services for UAS and other technology that maximizes forensic mapping efficiency. Also on the line with us today, we have subject matter experts Brian Roselli and Chanel Cordonnier. They will be answering your questions behind the scenes as well as in the live Q&A following Andrew's presentation. We do welcome your questions during today's session. If at any time you would like to ask a question, please enter it in the questions box, which you should see on your screen. If we are unable to answer all the questions in our live session, someone will reach out to you after the webinar by email. Now, before we get started today, we do have a few quick polls we'd like to ask to get a better idea of who is in the audience today. Our first poll is, what is your area of expertise or your primary area of focus? Go ahead and take a moment to answer that for us. Looks like we have a lot in the audience today who are involved primarily in crash scene investigation. I'm going to close that out and share that poll so that everyone can see what we're looking at here. Our next poll is, do you currently have a UAS program? Maybe you are just getting started, maybe you're moving on to figuring out next steps and best practices, or maybe you haven't even started yet, but go ahead and answer that poll for us. Looks like a lot of people are trying to figure out their next steps and those best practices. So this webinar today should give you a good start on that. I'll go ahead and share the results of that poll. And then we have one more before we get started. And that is, if you do have a UAS program, which photogrammetry software are you using? We have a number of different softwares listed here. They're probably the most popular. If there's something on this list or you do not see your software on this list, you can enter it in the chat box or just decide not to answer, but we would be curious to know which software you're using. It looks like we primarily have Pix4D in the audience here today. I'm going to share that result, and with that, I'm going to go ahead and turn it over to you, Andy.
Good afternoon, everybody. My name is Andy Klain, and I just want to thank you and Leica Geosystems for coming to participate in this webinar, and Leica for putting it together and hosting. So, especially in today's climate, as we should say, there's a lot more of this going on, and I know that there are a lot of choices that people have, so I just want to thank you for coming to spend your time with us. So just to get started, we're going to talk about the best way to, first of all, to start talking about the best way and different types of equipment that we could use for different types of crash and crime scenes. The primary topic today is how to bring in orthomosaic images from photogrammetry software like Pix4D, but we're also going to cover, some other uses. There are other tools you can use because you can't always use a drone. So we're going to start now and just talk about some different types of scenarios and what some options are that you can use to get the best results. So to start out, well, let's talk about in general first, what type of scene. And when I say that, first of all, most of our, crash scenes are outdoors, obviously. If you're here and interested in crime scene work, the drones aren't really going to be your choice indoors, but you have other options such as laser scanners or total station or taking hand measurements for something like that. Most likely the scanner would be the best option. But in your outdoor scenes, you want to take a look and see what the scope or what the area is that you need to map, if it's a large or small scene. What I mean by that is if we are trying to map 2,000-3,000 feet of an interstate highway because a crash had occurred and it continued for such a distance, or there was some issues with approach with curvature of the road or grade of the road or whatever, and you needed to capture a large area, that's a perfect scenario to use the drone or the UAS, because with that technology, you're going to fly the drone. It's going to take a series of photographs in a flight application, and then those photographs are going to be stitched together in Pix4D, and it's going to give you what's called an orthomosaic of your scene. So now you're going to capture a large area. That orthomosaic will be to scale and perfectly 90 degrees to the ground. Also, the Pix4D aerial photogrammetry software will give you a point cloud, kind of like you used to seeing out of a laser scanner. The difference is that the resolution or the detail of the point cloud versus the detail from a laser scanner are different. But to cover an overall area or a large area, the detail of that scan for the whole scene is good. But if you had a situation where now you had access to a laser scanner as well, you could fly the scene for the large area, and then you could scan the area of impact and rest where you need more detail, and then you could combine those two scans together if you want to work in a 3D environment. And if you're in a 2D environment, that orthomosaic image is going to take care of what you need to do. And obviously the drone, and we'll get to it shortly, is going to give you a faster processing time. But some of the scanners like the Leica RTC 360, it'll scan in 1 minute and 51 seconds your points and photographs. So the time that it takes to scan has gotten much better as well. But it's like anything else that you got to pick the correct tool for the job. Okay. The other thing to think about too is that we're also used to mapping, whether it's with a total station or what's called RTK GPS or GNSS, which is a network corrected GPS measurement. So the accuracy is a couple hundredths of a foot. As we all know, a regular GPS is 3 to 5 meters or 10 to 15 feet at its best. So that's why we need to have the corrected GPS. And those are other tools that you could use at your scene. And all of this can be incorporated into your maps. So while we're there and we're going to be looking at this, large or small, the time that it takes, some of the things that we need to be cognizant about is, when can we use this technology? So drones, obviously, there are a lot of issues because we're flying. We have a flying camera. So to do that, certain factors can cause a problem. Weather's a big one. The drones, most of these drones are UAS that people are using, the DJI, Autel, most of these drones cannot fly in precipitation. It'll destroy the drone. And also, if it's raining hard enough, you're going to get water and everything on the lens. There are several drones out there that are, kind of weather rated, but they're very expensive, and they're not going to give you, you're not going to get the best results because of the water or snow or whatever it is on the lens. And also temperature. Temperature can cause an issue with drones. If it's really cold, your flight time is decreased, and the ability for the aircraft to fly. Some of them, there's not enough. If it's too cold, the aircraft won't even start because the batteries are too cold and it could be a problem. Also, the scene that you're working at, tree cover, obstructions, obstacles. So if you have an area that's a more rural area and there's a lot of heavy foliage or tree cover, what's going to happen is you may not be able to see the details of the roadway from the drone at the altitude that you need to fly. Sometimes you can get under the tree cover. It's a little bit more difficult to do. You need to have a little bit more skills as a pilot, but most of the time that the tree cover can be an issue. And also the altitudes that you need to fly. If you have a lot of obstructions in the area, that's going to cause you to fly higher, and then your resolution of your drone camera is going to go down because of the altitude, and you won't get as much detail. The other thing too is lighting. So with lighting, it is with a drone taking photographs, it's no different than taking photographs with a camera. You need photographs at night need to be taken a certain way, and it's more difficult to do that with a drone. So what you see people doing is they are mapping evidence on the ground with a total station or a GPS or a scanner, and then they're going back in the daylight and flying the drone mission and then combining them together. But the lighting, at nighttime, the drone may not be your first choice. And finally, GPS denied environments. So all of the drones on their flight software are flying a flight plan that is pushed up to the drone, and it needs GPS to know where it's going and what positions it needs to be in. If you're in a GPS denied environment close to buildings, interference, one common one is a radio tower, high tension lines, cell phone towers, they will throw some interference either in your connection to the drone or potentially the GPS. So now you're going to be in a situation where it's not going to be a choice. Yes, there are some drones you can hand fly without GPS, but again, you have to look at the right tool for the toolbox. So there's some other key considerations that we want to think about as well in regards to the drone use. So the whole idea of airspace and authorizations, and I'm sure most of you know, it seems like, most people that are here understand this or may have a remote pilot's license, a Part 107 certificate now, but as public safety, you do have to have a Part 107 remote pilot certificate. There are still some misconceptions out there that the fact that you're in public safety exempts you from having a remote pilot certificate, and that is not true unless you are flying under what's called a COA, or condition of authorization, with your department. And there are some larger departments that have that, and those of you that have it know it and how that works, but you need one or the other to be able to operate a drone for doing this type of work. So then we get into issues with airspace, what's called controlled airspace, areas where the FAA has determined that you're not going to be able to operate a drone, and that could be at certain altitudes only. It could also be because of what's called a TFR, or a temporary flight restriction, which are used for dignitary movements, security for events like baseball and football, and other security issues for the country that you would not be able to fly. However, as public safety, there is a way that you can get a waiver, an emergency waiver, and it comes from a group of the FAA called the Special Operations and Support Center. And we are going to provide, after the webinar, in several methods, this information for anybody that wants it, and it's going to have all the phone numbers and a procedure that you need to follow to do that. And then finally, as far as airspace, you have the issue with the drones themselves. DJI, which is what most people fly, has no-fly zones or geofence no-fly zones. That has nothing to do with the FAA. It has to do with the drone itself, where they're saying that it's not a good place to be flying. It's near an airport. It's in controlled airspace, and you won't even be able to power your drone up. And with that, there's also a way for public safety to deal with that, and it's called the Qualified Entity Program, and we'll give you the information on that too. If you're flying drones for this type of work and you have not got your drone unlocked by DJI, it's something that you want to put on your list, because if you wait till you need it, you're going to be not too happy. So to move on a little, the whole issue too with some considerations is the time constraints and quick clearance. That's where all the drone stuff kind of got started. That's how we got started with it in Massachusetts, because of the fact that there's such a demand from the federal highway and state DOTs and across the country for what's being called quick clearance or traffic incident management. And we all know that when we do a crash reconstruction, we need to get evidence a certain way. It has to be collected efficiently and be accurate. And most of the time prior to this, if we had a rush, if you want to say, through it, there would be some type of negative side to our investigation. So that's the nice thing with the UAS, is that we can now capture more data in a shorter period of time in those situations that require the quick clearance. And honestly, the data that we're getting is better than we were getting with a total station or a GPS. And again, scanning is an option. A lot of people do both, like I spoke about, and the times are getting faster, but the drone is really going to give you that quick clearance time for the scenes that you know it. And then also, we want to talk about the use of the output, or what I'm trying to say is, what do you get from the drone? So from the drone, you get that orthomosaic image that I spoke about. You get a point cloud, which is similar to a point cloud from a scanner, and you have both of them, and we can combine them together. So it's up to you to decide what you want to capture or how you want to capture it. Pix4D will give you both at the same time. Obviously, a scanner will give you the point cloud, and then the idea is that we can use these different sources of information or evidence to do our crash reconstruction. So I think we're going to take a break right now and go through a few more poll questions.
Yeah, just one quick poll that we have here, and that is, how are you capturing ground control points? You should see that on your screen. Take a moment to answer that question. Looks like we have a lot of people using total stations, and Andy will talk about that next. So I'm going to go ahead and let you go through that, Andy.
Okay, great. So the reason why we asked that question about ground control points is ground control points are key to an accurate photogrammetry, aerial photogrammetry project. Ground control points, think of them as anchors. They're anchors in our scene that have known position, and we're going to get into that in a second. And because of the known positions, that allows the software to use those positions, which are going to be three-dimensional in most cases, and process the project in Pix4D to give you an accurate representation of the scene. And when I say accurate, we're going to be going to a survey grade accuracy. I like to call it an evidentiary grade accuracy. We're going to get to hundredths of a foot, and we're going to be able to testify to the fact that these diagrams are accurate. So first, a ground control point, I had said it's a known point, an anchor, but in the photogrammetry software, you need to have targeting or some type of marking in the area. If you look at the bottom right of that slide, it's a little hard to see, but you can see there's 3 targets there that we would then either use our total station or GNSS GPS to capture the location of those points. So the theory is that those targets are in your software. We would then upload a data file to Pix4D with our ground control point measurements, or coordinates is a better word. And then we would identify those targets and pick them in the software, and then Pix4D would run from there. And honestly, that's really the only manual thing that you're going to do in Pix4D is mark your ground control points. So how do we do this? It sounds like a lot of you had indicated in the poll that you were using a total station. So let's go through this. The best way to do it, or I should say the most accurate and best way to do it, is to use the GPS, the RTK GPS. And the reason for that is it is going to give us position in X, Y, and Z to a couple hundredths of a foot, and it'll be in what's called state plane coordinate. So state plane coordinate is a coordinate system that every place has an exact position. So if we're in a known coordinate system, and now we have evidence or media or anything from that's in state plane coordinate, then it will all be able to link up together in different softwares that you're using, like Map 360 is one of them. But that allows you to be able to have a coordinate system. We're so used to in crash reconstruction using an arbitrary coordinate system where we set up our total station at 0, 0, 0, and then we shoot our evidence from there. There's nothing wrong with that. It's just in a local coordinate system. So if you're using other data sources, it's a little bit more difficult to bring it together. But the total station and the GPS will give you 3-dimensional ground control. So those are the recommended ways to do it. And then there's one other way. If some of you don't have a total station or a GPS and you want to use Pix4D or other photogrammetry software, you need to have some type of way to show a jury that your work is accurate. So what we can do, similar to with a total station when we used to put out a 50-foot check measurement or a 100-foot check measurement, check it in the beginning, check it at the end, that is in fact that distance. Excuse me. You can do the same thing in Pix4D with what's called a scale constraint, and you're going to tell it that the distance that is measured in the software is in fact, let's say the software says it's 49.97 feet and you're going to measure 50, you're going to tell it it's 50, and then it's going to go ahead and scale that. But it's only scaling it. It's only scaling it in two dimensions. So that's why the GPS and the total station are better choices. And the other thing with the GPS is, like you see there, that's the GS07, the CS20 data collector. It is going to capture all that for you, and then once you have it down, it will align everything up. And you'll also see in your Pix4D reports that it'll give you a quality report that'll show you how accurate you are. And the other thing with that is you only need one person to operate it, and it can be used to document evidence just like a total station. So I think we've hit that pretty good. And my takeaway is make sure you're doing something. Don't just run a Pix4D project and bring it into your CAD and just assume that it's okay, because it usually is, but I can show you tons of cases that it's not, and you need to be able to validate what you did. So choose one of these 3 methods, but don't just take it on its face. All right, so now we're going to talk about the import options that we have. And I'll try to go through this quickly. So I had talked to you about the 2 things, an ortho image and the point cloud. With this, we're going to just stick in the ortho mosaic image category. So when you use Pix4D, and other photogrammetry softwares are similar, you're going to get a orthomosaic image, which means that all the images are processed so they're 90 degrees to the ground, and then the software stitches them together into one large image. And with that, in Pix4D, if you use RTK GPS, you're going to, or actually, well, let's stay with RTK GPS. You're going to get a TIFF, which is like a JPEG, but it's a TIFF file, it's an image file, and you're going to get a positioning file that tells it where in the state plane coordinate system that image is located. So once I have that, and I'm going to show you shortly how we can bring that into Map 360, and it will place it in state plane coordinate in the right location. and we'll verify that through the GPS points that we're going to show you. When I say geo-referenced ortho, you can also do this with a orthomosaic that you use the total station to get your ground control. Then now you're going to be in a local coordinate system at 0, 0, 0. And if your total station was at 0, 0, 0, and so was your image, those will line up as well. So that's another option way to do it if you don't have the GPS. And then the final way is kind of the way a lot of us were doing this when we were using Google Images and total station data, was you're going to align it. You're going to come into CAD, you're going to bring in the image, you're going to scale it, and you're going to align it to known points in your total station or GPS file. And then in Map 360, it's called an align command, and it'll align and scale at the same time. And now it's going to drop in your image. So there's a couple of different ways, depending on the gear that you have, on how you can do this. And just on the left bottom of the slide, you'll see those are the files from Pix4D, the TIFF file and the world file, and then some TFW that gives its position, so it knows where to go. So I think at this point we're going to do a few more poll questions, and then we're going to jump into some demonstration on how to do this.
Our last poll question for the day is, how would you describe your experience with laser scanning? Because we've been talking about drones, but we do have a little bit in this presentation as well on point clouds, and we're just curious about your experience with laser scanning. And perhaps you haven't even started to explore it yet, and that's fine too. We're just trying to get a gauge on where you are right now. Looks like a lot of people are in that beginning stage. All right, so with that, I'm going to close the poll, and Andy, I'm going to turn it over to you again.
Okay, thank you. Okay, so we're going to start in a diagram that we have a blank diagram that we're going to start with. And what I want to do is show you how we can import the orthomosaic image into Map 360. So the way that we do that is pretty simple. I'm going to hit import export, and I'm going to go to attach image. And I'm going to get a dialog box that comes up, and then I'm going to browse to the location of where the image is from Pix4D, and that is this image right here. And I hit open, and now I'm going to get another dialog box. Now you can see right here that it says use positioning file. It's automatically checked, but if you don't see that checked, you want to check it. And then that's going to tell it where to put this in state plane coordinate into my drawing. So once that I hit OK, and I can double click, have it zoom extends, and then there is my scaled orthomosaic image of a mock scene that you can see in your screen. As you can also see, I know it's over a computer, but the detail of this is highly accurate. It is what's called ground sampling distance of 1 centimeter. So that means there's 1 centimeter between pixels. And just to give it some perspective, a Google image is 30 centimeters. This is 1 centimeter. So you have pretty good accuracy, which means that I can zoom in very close to get and detail in the image. So now what I'm going to show you is, now we have the image. Now let's assume that we used a GPS, the GNSS system, to get our ground control, but we also took points with it. So now I can go and I can overlay the points into my drawing in Map 360. And the way I would do that is just say import. I'm going to tell it the coordinates are comma delimited, meaning there's a comma between them, and it's just a text file that is in the correct order. So it's going to be XYZ or YXZ. My points are YXZ. It's northern eastern elevations, pretty standard. So now I'm just going to select that, and I'm going to go and I'm going to grab those points. One second. They were right here. Sorry. There we go. All right, and they're in, and just as you could see, my bad, it's good to stay organized where your stuff is. I had it all in one folder, but as you can see, a lot of stuff gets in there as these open, so you need to keep that straight. But now that you can see, it just imported them in. There's no alignment, no manipulation, nothing. Once they import, they're going to drop in, and as you can see, as I zoom in, that the point for target GCP number 2 is right smack dab in the middle of GCP number 2. And that's because the image and the points are in the same coordinate system. That yellow 63.8 is the elevation above sea level, the exact elevation that this scene is at, rather than how many feet above the 0 point that you set your total station up. So let me zoom in here a little bit as well. And if I go zoom a window, if I come into this area here, I can show you that also we have edge of pavement shots. We also have our GCP, and this one is actually on this bound, this pink painted surveyor's bound, and the sign's just pointing to it. So you can see that this whole thing is all to scale. And then just to actually, let's show you to take it one step further. We can also bring in a point cloud on top of this, just as long as it's in state plane coordinate, as long as it's in the same coordinate system, we can bring the point cloud in. So I'm going to do that. And again, this was all Leica. This was done with the Leica RTC 360. So it's as simple as just grabbing the file and bringing it in. And okay. And you'll see it populates the point cloud, but what's happening now is the photo is on top of it. So I'm just going to click the photo, and I'm going to tell it to send it to the back. And now you can see that the 3D point cloud from the laser scanner is sitting right on top of the image and is all lined up with our GPS points. So just to show you too as well, if I go and take what we did, I made a little mock scene on top of the ortho image from this and just created it up. It's supposed to look like a pedestrian crash, and you can see that all of the features you can draw right on top of the image. Now, a lot of us were used to, if I shut that ortho image off, we're used to looking at something like this that's kind of like a stick drawing, edges of road and whatnot. And some people would fill in the sidewalks and the roadway, but it tells a much better story having the image on in the background where everything is. So this is something that you can do with an ortho mosaic image that if you didn't have that, that's part of the benefit to doing this. It actually looks like the scene you're at. One more. This here was from an actual crash scene that I did a momentum analysis with. So again, if I zoom a window in here, you can see that I was able to plot the impact and rests from the evidence at the scene. You can see the paint marks on the road where the evidence was marked. Let me just zoom in one more time. And the furrows and the stuff through the grass. And now you can see I measured all my angles and distances here and was able to put that into and do my calculations for conservation of momentum. So I just wanted to show you what you can do with this for real, so to say. All right, and then just one more thing to show you for those that are laser scanning with Leica. There's a new feature now with Register 360, which is their scan registration software, that I can actually go and create an ortho image of the scan. So what you see here is the scan sliced down from a top-down view, and now I could do my diagram on top of that, just like I could do with Pix4D ortho mosaic. And this is all to scale, and this one's geo-referenced, so it would line up with everything else. So this is something new that is out, and people will start using. So that's what I have for you at this point, and I think we're going to be moving into question and answer period.
Absolutely. Thank you, Andy. We do have a number of questions that have come in as we've been speaking today. I'm going to ask the panelists as well as Andy to go ahead and share the webcam for this part, just because it's nice to be able to see everyone, especially these days when we're all socially isolating. So, all right, one of the first questions that we have here, Andy, if you could share your webcam as
Yep.
well.
Yeah, I'm working on it. There we go.
Okay. And I'm going to go ahead and share the contact screen that we have just so that everyone can contact our presenter and our panelists at any time after the webinar today. So one of the questions that we have is, what is the largest file size that can be effectively imported into Map 360? Chanel, I'm going to go ahead and have you address that one first.
Yeah, for sure. So Map 360 can handle enormous file sizes for these ortho images, and these ortho images can range in very different sizes, whether you're going to be capturing just an intersection or a couple blocks, as Andy said, with the scope of the scene. So for myself personally, I've brought in an image that was 8 gigabytes with no issues and did a diagram with that, but I know there are a lot of customers that have brought in even bigger files than this. So Andy, I'm sure you could even speak to this if you've brought in some bigger files than 8 gigs.
Well, I would say, honestly, most of the scene files from Pix4D are going to be 700 or 800 megabytes. You might, on average, if you started to get a very large scene, you could get into a few gigabytes. And as you said, I've never had an issue with it not accepting the image, slowing down when you're using it, or just going into the blue screen of death, as they say. It has never happened with this software, Map 360, at all. It does a nice job with the larger images.
Okay, excellent. And then we talked about importing data from multiple sensors, but is it also possible to import multiple images? Again, this is a Map 360 question, so I will field that over to Chanel first.
Yeah, absolutely. So as we were mentioning with the type of scene, if you have a larger area and maybe you want to do a little bit less detail, you could fly the drone a little higher up and get a bigger area for the scene, and then do a lower flight closer to the area of interest. And you could bring both of those images into Map 360, and if you have the ground control points, they will align perfectly, and you'll have the less detailed area around it, and then the high detail on top of the other image.
Okay, excellent. Thank you. We had some questions here. One of them is about PPK. Andy, I think this one is for you. Is PPK okay? And I think this was in relation to a little bit early on in the presentation. Do you need more detail on that?
No. PPK is what's called post-processing kinematics versus RTK, which is real time. PPK just rectifies or processes or fine tunes the coordinates to their accuracy post scene. It's not doing it live. You send it off to a service, or you do it yourself with different files. But as long as your coordinate file that you get is processed, then there's no difference at all. The difference is sometimes gathering the PPK data. There's several companies out there that have targets that have GPS units in them that you put down on the ground, but they have to kind of sit there and bake for like 30 to 45 minutes. Then you go and post-process them. So if time isn't a factor, that's fine. But if you're in a situation where you need to have a little quicker clearance, that the RTK or the GPS unit would work. But they both work. They're both good for ground control.
Okay, thank you, Andy. And you did mention a little bit about unlocking the DJI drone. One of the questions we had here is, do you need to contact DJI to unlock NFZ?
Yes, it has to be done through DJI. We're going to post the information so you can do that. And it basically, you're going to have to fill out paperwork that they're going to want the serial number of every controller that you have for each aircraft, and they will literally go and unlock that geofencing for a year. So it has to be done up front, and they're going to require official letterhead. They're going to require the serial numbers. So we'll give you directions to get to the location to be able to get instructions in the forms that you need to do that.
Okay, I'm going to send this next one to Ryan first, and then he might decide to have Andy comment as well. But the question is, we're commonly told that aerial mapping is always faster than laser scanning. What do you feel is an accurate ratio of flight time to GCP collection with total station? So I guess this isn't necessarily a laser scanning question, but it would be good to address, is laser scanning always less
Well,
fast?
no, I think it's a great question, and in the world that has the RTC 360, I mean, you can scan a single position in 26 seconds. That's our low resolution laser scan time. That's without an image. If you add the image, it's a minute 26. And because the RTC has viz registration inside, you can do 6 scans in under 10 minutes. And a lot of times, 6 scans accommodate your entire scene. But there are scenes that doesn't accommodate, that are more complex, and where UASs do fit that bill. I would say that they both have upsides as far as speed on site. But for me, and being I was trained first in total stations, came up through laser scanning. I now work with all of it. I definitely think that the RTC is a game changer as far as speed on a scene, but the flexibility you get from being aerial and shooting down over different circumstances, different terrain, that you with a laser scanner, it's terrestrial laser scanning. You actually have to be there with the scanner and have line of sight. And the UAS can help overcome some of those issues. So again, they each have their place. They're both exceptionally fast, and one may be faster than the other depending on circumstance. Andy, do you want to weigh in on it and talk a bit?
No, I agree 1,000,000% with what you said. And the takeaway I have is the right tool for the right job, or several tools for the right job. You have to look at what you're trying to do and address that. But laser scanning has become way faster. And if I'm wicked fast from Massachusetts, I will say. But it's changed. So you have to look at what you have available to you and how you want to deploy it.
Certainly.
Okay, excellent. There is someone who wanted to clarify what drone and camera was used for the demo imagery that you presented in this session, Andy?
Sure, it was a Phantom 4. I'm sorry, no, we flew it with 2. That one that we just showed you was with a Mavic 2 Pro, and that was flown at 90 feet AGL, or above the
Okay.
ground.
Okay. And then we have someone here who wants to know, how do you share results with your clients? Do you use a PDF, cloud links? What are best practices there?
Well, with the drone, with Pix4D, you could share the images, you could share the ortho images themselves, and you could share the point cloud file, but they would need some type of software to open it. So something like Map 360 or other types of CAD software that can take images or point clouds. And you also have the option of you can PDF out some of it, and you can take screenshots out of it. But Pix4D is a processing software. It creates those deliverables, the orthomosaic and the point cloud, and then you would need other software to do that. Now, Ryan, if maybe you could grab this one as far as the laser scanner. What can we do?
Well, no, it's a great question, and really a lot of it does lie within the Map 360. If you push what you have into Map, Map 360 allows you to create just a wide range of deliverables, whether it be perspective views of different aspects of your scene, evidence reports in which snapshots are integrated with mapping data, PDFs that are, you can have point cloud overlaid with drawing. You can have your ortho image overlaid with your drawing. And let me tell you, that's gotten to be such a popular way of sharing, where you have the ortho rectified image comes in, you create your map over top of it, and you actually publish as your deliverable the combination of the both of them. The images that we're getting are so clear now, whether they're flown at 90 feet or it's a laser scan data set that we convert into an ortho image. that image combined with the symbols and the drawing that's done in Map 360 creates a very, very powerful deliverable that we have layers within our PDFs. They're, you know, our PDFs are not just standard 2D one sheet PDFs. You can turn layers on and off. And so you can turn off the point cloud or image layer, depending on what you're using. So now you're looking at just the map. So you have options within even that PDF where you're showing things in 3D perspective, you're showing snapshots, you're showing things layered. And it's just kind of a Swiss Army knife of deliverables within that a bit more complex PDF where a lot of those options lie. If you are trying to share a point cloud, we have our LGS file format, which is an open source, or not open source, but you can download our Jetstream viewer, which is freely available, I guess is what the way I meant to say it. And that LGS file can be opened on anybody's computer that has the Jetstream viewer, which again is a freely available program from Leica, and you can navigate point clouds using LGS file types within that Jetstream viewer. So wide range of ways to get into your data. Really a good, powerful method of sharing is right out of MAP using the multitude of methods that you can push into. Chanel, do you have anything to add to kind of that description of the MAP sharing?
You kind of nailed it there, Ryan. The only thing I would add is just with the evidence reports, they are a great way to share a file and share a scene. With evidence markers, you can attach other documents from the scene or other photos that were taken directly at the scene. So that can all be compiled into one document, and then that PDF, when shared, you can give access to the full resolution images just through an embedded link in the PDF file. So the PDF is very powerful, as Ryan was saying.
Okay, great. We have a question here about the ground sampling distance. Andy, would you say that 1 centimeter is the go-to sampling distance to use?
Right, so what Pix4D recommends is trying to process to a range of 1 to 3 centimeters for your ground sampling distance. You can go lower. What happens though is if you go too low, the software can't discern the difference between the pixels because it's so tight. But I've processed scenes where you're flying low orbits to get detail and you're at 0.75, 0.85. It still processes. The whole goal is to get a lower ground sampling distance so you can then have the detail. You could kind of look at that as the lower the ground sampling distance, the more you can zoom in and see detail. So that's why that's important. And it's telling us the distance between adjacent pixels. So each pixel next to the next one is a centimeter apart.
Okay, great. And we have a couple of questions here about point clouds. One of them is it possible to bring in a point cloud from Pix4D and combine it with a point cloud from the Leica scanner? Ryan, do you want to take this one first?
Yeah, sure. I mean, you know, point clouds are a point cloud is a point cloud once it's created. I mean, you know, certainly depending on the source, you have the quality of that cloud that you have to be concerned with, because the way that a point cloud is created, if you have misalignments or aspects that aren't fully rendered, trying to bring 2 point clouds together that aren't on equal footing can present some challenges. But you know, once you're in that point cloud form, if you get to a format that can be equally read by a program for bringing clouds together, like Register 360, you can bring them into that environment. In this instance, I would imagine it would be you know, the Leica point cloud, and if the Pix4D point cloud was converted into an E57, they would be put together in Reg 360 and be merged or registered into a single entity. So yes, it's absolutely possible. You know, the thing with data is, I think we're finding more and more that there's a way to convert, you know, any format of data into the format that's needed to do things, you know, to make that data more useful. It's just a matter of finding the way to convert it or making sure that you know what format you need to be working in. But yes, it's an absolute possibility.
Okay, and then with regard to Map 360 specifically, does Map 360 offer animation or simulation software to work with the point cloud generated from Pix4D? Chanel?
Yep, absolutely. So Map 360 can bring in the point cloud from Pix4D or Like Ryan was saying, it could be combined with other point cloud data and then brought into Map 360. And Map 360 does have animation capabilities and a separate module for animation. So very sophisticated animations can be created with the point cloud data, but Map 360 does not have a simulation engine built into it. There are other.
I think it's important to note the difference between simulation and more, I guess, animation. When we talk about animation within our world, we're talking about dynamically moving through static environments. So when you hear the terms fly through or animating a point cloud or building an animation in Map 360, it's about building a dynamic view of a static environment. The simulation is really kind of trying to simulate real world events in this animated form. And so there's physics, there's a variety of biomechanics that might need to come into play. And as Chanel was saying, we don't do that in Map. We can animate things, but we don't simulate things.
All right, here's a little more complex question. I'm going to send this to Andy first. Is it true that without GNSS or GPS, GCP, that while it won't match with state plane z-axis, the point cloud accuracy is not affected for z-axis point values within the local map?
So as long as you use a total station and you're getting 3D points in a local coordinate system, it is fine. It works the same as a GPS, except it's in the local coordinate system. If you go to a scale constraint, you are not getting that Z value. And the other issue with that is that DJI drones inherently are anywhere from 40 to 100 feet off in altitude, and it's all relative. So the whole scene is not where it's supposed to be. So if you use a total station or GPS and you have X, Y, and Z, you can account for everything. It's just if you're using scale constraints that your elevations could be off quite a bit. And if you have a large scene, you might find that you're getting some type of twisting or bad processing because there's not enough ground control to lock it down.
Okay, and here's a question about ortho scale. In the case of a hill crust, when the ortho is flattened, it seems to skew the ortho in that the control points on the grade at the edges of the mosaic no longer align with the GCPs. Can you comment on that?
Sure. So anything along the fringes of the flight or the project are going to be off because there's not enough overlap or detail there for it to process. So what you want to do is basically overfly, over process, and then when you get into pics, we can set what's called a processing area and have it locked down. But if you're trying to rely on stuff that is along the fringes of the flight, it's not going to be correct.
Okay, excellent. We are getting close to the end here, but we do have a few more questions, so we're going to try to cover them quickly. One of them is, what kind of photo capture is useful to capture the location in linear or orbit mode?
What type of photo capture? Can you read that again?
What type of photo capture is useful to capture the location in linear or orbit mode? We might need more clarification for that one.
Yeah, I'm just thinking that sometimes people will do an orbit of, especially if you have like a crash where you have your vehicles at rest. When you do just a grid flight with the drone, even if it's a 3D grid, you lose a lot of the points on the faces, on the facade of vehicles and along the sides. So people will fly in orbit over the area of interest with the camera at about a 45-degree angle. I'm thinking what they're asking is that, how do you do that? Well, when you fly the orbit, you want to have the same overlap of about 80% on the side. So I just use DJI, it's Go 4, and I set up a orbit flight and I have it automatically take a photograph every 2 seconds and I get really good overlap. So I'm assuming that's what they're asking.
Okay, excellent. And we have someone here who's using a scan station, like a scan station P30 and DJI drones, and we don't have RTK or total station. Can you go over the best way to get ground control points again?
Well, I could tell you, and Andy, I'll let you answer here in a moment, but with the scan station, I actually did this about a year ago. We had a scan station out and a DJI drone, and we scanned those in, and we actually created the GCPs from the ground targets in the registration software, and it worked amazing. I don't know if Andy, if that's similar to what you've done with that using scan station and DJI. Coming together, but it was quite amazing. I mean, the scan station can scan at such high resolution. Those GCPs were just, it was almost like a solid surface, like it had been modeled, and the data sets overlapped perfectly.
Yeah, so just to just build on that just a little bit. So in Pix4D, you can have a ground control point, which was something that you shot. You can have what's called a manual tie point, which you're just selecting an item in there and putting a control point on it. So like, let's say I had the corner of a catch basin, or I had the end of a skip mark, or if you had that, then when you get that point cloud, what you're saying, Ryan, is exactly it. And you're just gonna pick common points or common control points, and the software will merge it together.
Okay, excellent. We are just about at the end of our time here. I know there are a few questions we did not get to today. Some of them are a little more complex, and so we will have the organizers and panelists reach out to you after the webinar by email. Andy, do you have any final thoughts about the topic of today's webinar? If you wanted one key takeaway for the audience, what would that be?
I think that in this world of crash and crime scene investigation, reconstruction, diagramming, is you have to look at the tools you have available to you. There's a lot of people that were thinking when they first heard about photogrammetry, and we get calls here at the office, well, that means I can get rid of my total station, and that means I don't have to pay that subscription, and I don't have to do this. That's not true. These are all tools that you have, and my takeaway is that you need to know what tools you have, and hopefully this helped you see how you can integrate some of those tools together.
Okay, excellent. Thank you, Andy. This does bring us to the end of today's webinar. We would like to hear your feedback, so please do take a moment to complete the brief survey that should pop up on your screen. If you would like to learn more about mapping with drone imagery or point cloud data or any sensor data, please contact our presenter directly, or visit forensicmappingsolutions.com or psg.leica-geosystems.us. We appreciate your time and hope that you found this webinar to be a valuable experience. Thank you, everyone.
Thank you, everyone.
See you all later.